Hello everyone, welcome. We are the Calm Mind Tutors. On the introduction part of this series, we talked about different methods to calculate rotation and deflection. In some of these methods, there is a requirement that you draw a bending moments diagram. And also there is a requirement you first calculate the support reactions. And for you to be able to flow in what we are doing, you need to know how to calculate the support reactions, know how to calculate the bending moment. So today I will show you how to calculate the support reactions. Okay, let's move on. So this is an example of a beam. This is a simply supported beam with supports at the extreme. So we are asked to calculate the support reactions in this beam. First, what you need to do, you draw the free body diagram. And the free body diagram, what you needed to show there is you show the support reactions, you show the loading, you show the dimensions and the beam. So solution is the first thing you're going to do. Solution, you draw the free body diagram. Free body diagram. So this is the free body diagram. You show the reactions, the loading, and the dimensions. So once you have done that, first we are starting with what we call determinate structures. We are starting with determinate structures, and for a beam, there is a formula to check for determinate structures. What I mean by determinate structures is a structure you can determine or obtain its reactions, its support reactions, using the three equilibrium equations. So looking at this is a determinate beam. So we will use the three equations of equilibrium to determine the reactions. So first I'm going to begin with the summation of moments. So I'm taking my summation of moments at A equals to 0. So I'm going to use the sign convention that the clockwise motion is positive and the anti-clockwise motion is, this is clockwise, this is the anti-clockwise movement. So this is the sign convention we are going to use. So looking at the free body diagram, this is my point of reference. So before we continue, there are the points I need you to note down that when a force is passing through the line of action, then the moment at that point is 0. Being that I have this is my reference point, I have a force coming in these two directions. You see, this is actually, this is this horizontal force coming this way. If you look at this joint here, this is the joint. Then this one we tend to push in this manner. There is no rotation. Then at this point here also, this will try to push it out from the pinpoint. There is no rotation. So moment is about the force multiplied by the perpendicular distance. That is the key, the word perpendicular distance. I have this here. This will cause a rotation at this point. Just watch my hand here. You see a rotation at this point. You see? Because it is loaded, it has the perpendicular distance from here to here. Okay, you get that point. So that is the reason why the HA and BA will not be included, because this will not cause a rotation, and this also will not cause a rotation at this point. So this force will cause a rotation to this point, and it's going to go clockwise. I'm going to take it as a positive motion moment. So we have 60 multiplied by 1, the perpendicular distance. Then you have the next force, which is 90. It will also go in a clockwise motion. Then you have plus 90 multiplied by the perpendicular distance, which is 3, plus the force 50. It will also go in a clockwise direction. We have 50 multiplied by the perpendicular distance 4. Okay, then we come to the vertical reaction at B, which is VA, and we go in this manner, which is anti-clockwise. We're going to give it negative VB multiplied by the perpendicular distance, which is 5. Then we go to 0. This becomes 60 plus, then we have 27, that is 270 plus 200 minus 5 VB equals to 0. When you calculate all this, you arrive that VB is equals to this. Then we use the next equilibrium equation, summation of forces in the vertical direction. So summation of forces in the vertical direction is equals to 0, with the convention that any force going upwards will have a positive and anyone coming down will have a negative. So the VA is going up and the VB is also going up. So we're going to use a positive VA plus VB. Then the applied loads are in downward direction, so it's going to be a negative values. We have 60 minus 90 minus 50 equals to 0. When you simplify all this, you arrive at VA is equals to this. So these are the ways you can calculate the support reactions. Thank you for your time.